Okay, fine. So this is the program I feel correct, right? You had developed the object program for the yes, all of you are there. Yes,
Yes,
yes.
ma'am.
Yes, all
Yes,
of you are
ma'am.
there. Okay. So develop the object program for the source program given below. Okay. So they have not mentioned whether it is SIC or SICXC. I yes, the question is have they mentioned SIC or SICXC? No, they've just given the question, and you can identify SIC or SICXC based on the number of instructions. Okay. Sorry, the type of the instruction, that is either it is register to register or indirect, okay, and immediate. Fine, ba? So based on that, you have to make out the instruction type. Okay, fine. So that's why based on that you will come to know whether it is SIC or SICXC. So here I think we'll just cross check ba whatever you people have done. Done only the first two columns because I want to cross check with you people so that we will do. Okay. So yes, I can you see the screen? Can you see
Yes,
the
ma'am.
screen? Yes. So I think the first one is 4 bytes, right? And you don't have an what is that a length or object code for any of the assembly directives, right? So do you have for this? No, because base is my assembly directive and start is my assembly directive, right? And LDA it is 3, and next compare a comma x it is 2. Then next is it is memory address, it is 3 bytes, and next again memory address 3 bytes, this is also 3 and this is 3, and this is again 3 memory address plus immediate, and this is again 3, this is 2 because it's a register. Okay, and R sub is 3, and reserve word is it 2328, am I right? 2328, am I right? Yes, Neha?
Yes, ma'am.
Yeah, you have to answer because you people said that you will do it and come, right? You haven't done, or you people are copying from here?
Ma'am, the clear X instruction, we haven't written that.
Yes, ma'am. This is an extra instruction. Clear it.
Oh yeah, okay.
Yes, ma'am.
Oh, then my whole anyway, you just include, no? That's okay. Oh yeah, for you people it will be changed, no?
Yes,
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 ma'am.
you
ma'am.
have written
Everything
the
will be
object code
changed.
also.
Yes,
Yes,
ma'am.
ma'am.
I'll just delete now. Shall I delete? Yes. Shall
Yes,
I
ma'am.
delete or you
Ma'am.
people will include? I'll delete better. Okay, fine, because you have already done your object program and all. No, later you can tell me this length. Okay, and R sub is there? R sub is there?
Yes,
Yes, ma'am.
ma'am.
Answer is there.
Okay, 3. And this is 2328. Am I right?
Yes,
2328.
ma'am.
Okay, next this is 4 bytes. Okay, because 4 characters are there here. So it is 4 bytes. And reserve byte is 200. So what you have to do? Do you have to multiply by 3? No.
Ma'am, even this isn't there.
Ma'am, there is some changes here, ma'am.
Max is not there. Here it's there. No max.
No, ma'am.
Max is there, ma'am, but reserve byte is not there.
Okay, what was it?
This is a word.
What was it?
After byte, it's word, ma'am.
This was word. Was it reserved?
Word,
Only word, huh? Okay, fine.
like the bill instruction should be above, ma'am. Like this zero, word, and zero should be above, and then comes max, ma'am.
Okay. This should be, what should be this?
After buffer, byte is fine, ma'am. After buffer, byte is fine, and after byte, there comes a word, ma'am.
After buffer, EOF is there.
Yes,
Yes.
ma'am.
Yes,
And then
ma'am.
after that, max is there.
Zero. No,
No,
ma'am.
ma'am. Zero word. Zero.
Zero
Zero
word.
word and zero.
Ah. Then this is zero. This,
Yes, ma'am. That instruction should be above that.
okay. This is zero. Done, ba?
Yes, ma'am.
And next
Yes,
is
ma'am.
max. What is this type?
Reserve word.
Okay.
And 10.
RESW. Reserve word. Then this
10.
will be 200, or how
10,
much is
10.
10? Okay. Next, what this will be?
Total length, reserve word, and 100. That instruction is fine. The below instruction.
So this is delete cell. Okay. And this is done, no? 4 is correct, right?
Yes, ma'am.
4 is correct. I'll just delete these values from here. Okay. Delete. Done. Till there it was correct. Okay.
Yes,
Then
ma'am.
EOF 0 is word 0. Right? Yes,
Yes,
ma'am.
ma'am.
Then
Yes,
max
ma'am.
reserve word 10. Right?
Yes.
And
Yes, ma'am.
this total length reserve word 100. Is it correct?
Yes, ma'am.
Okay, now you tell me the length. Okay, so this is 4 and this will be how much? This is 3,
3.
right?
3.
And this is 30.
1.
Convert that into
E.
what?
1
1
E,
E.
ma'am.
1E.
E. Okay, 30. Then this is reserve word and that will be 300,
12C.
right? 300
12C.
is
12C.
12C. Okay, yes. I hope
Yes,
now
ma'am.
it's clear. It's correct now, whatever I've done.
Yes, ma'am.
Okay, done. So this is 1000. Starting address is 1000 and the plus 4, 1007 plus 2 1009 and plus 3 100C. Okay, and plus 3 DEF, right? And plus 3 that is 101112, right? And next is 15, right? And next is this is 18, yes. And this will be how much, ba? 10
1B.
1B, okay, and plus 3, it will be BCD
101E.
101E, okay, next, what is this?
3346. 46.
3346, okay, next,
3348.
3348, okay,
A, ma'am.
okay, 10, no, for 6 plus 4, 10, okay, and this is BCD, right,
Yes, ma'am.
3348D,
4D.
okay, next, this will
336B.
33,
6B.
okay, done. Then this is
3497.
3497. Okay, done? Yes,
Yes, ma'am.
done. So, yes, all of you have written the same answer.
Yes, ma'am.
Okay, so what is next? Program length
Then
equal to end address minus starting address. Correct? No? Yes or no? Yes,
yes,
ma'am?
ma'am.
Okay, so this will be how much?
97.
2497. Okay, this is your then simple table. All of you have created simple table?
Yes, ma'am.
All of you have created simple table. I will not do it here. You want me to write simple table?
No,
No,
ma'am.
right? Yes? You want me to do simple table?
No, ma'am.
Simple table. Okay, I'll just put simple table. Next one. Okay, and what is this value? C loop. Okay, C loop. What is the value? What will be the value? All of you have done or not?
Yes, ma'am. 4B.
4B10
3348.
0 this one. Okay, 0 is 334A, right?
Yes, ma'am. Yes.
334A, 234. Yes, 1B
4.
10334A, right?
Yes, ma'am.
Yes, ma'am.
Yes, this is correct.
Yes,
Yes,
ma'am.
ma'am.
Okay. Yes, because I had done my value will be different. Okay. 3 only this will be different. 3414 is there, but for you that will be different. That's fine. Okay. Next, base. Do you have an object code for this? No. Okay. What
No,
is
ma'am.
LDA max? What is
034.
Is it base relative or PC relative?
That is base relative, ma'am.
Yeah, it is base relative. Okay. What is this value? 0. I'll just change. No, 3. What was that value? 30334A. Right. I'll just change here only. 334A. Okay. This will be 334A. Okay. And next is LDA max. Okay. Only this value will be keep changing. Displacement is equal to, you have written, no? Yes, this much you have written. Displacement equal to like this. Yes or no?
Yes, ma'am. Yes,
Okay,
ma'am.
so we'll just displacement equal to, what is the displacement? Displacement is my target address, right? Max, that is 334D, right? I'll just do it here only. X 334D minus PC. What is my PC? 1007. What is the value? 2346. What is this value? 9030. Right? Is it greater than 2047? Yes, sir. No.
Yes, ma'am.
It is greater than
Yes, ma'am.
2047. So you have to go for the base relative. How do you do the base relative? That is target address. What is my target address of max? 334D, right? Minus what is stored in base register? Max, right? So what will be that? Will be
3340.
334D. So that will be 0, right? Yes. Yes, but you have to make sure that you change this bit. Okay, I'll tell you where students will do mistake. See, initially we'll set this bit, no? Do you agree? Yes, initially we'll be setting this bit and we will be doing the calculation. Okay, then once we come to know that this is not PC relative and we'll consider it as a base relative, but you have to make sure that you change this bit. Okay, fine. This is a minor mistake what students do. Okay, fine. So you have to make sure that you have to change the B bit also. Okay, so what will be this value now? What is this value? 0?
034
Ah, 000, right?
10.
Correct, no?
Yes, ma'am.
Yes or
Yes, ma'am.
no? Yes?
Yes, ma'am.
So, next, compare a comma x. What is the a0, right? a0. I can directly write now a0. What is the number of a? What is
01.
0, 1. Okay, done, ba? So, this is the number of this register is 0, 1. Okay, next, jump equal to exit. Okay, so it is PC relative. What is the address, ba? What is the address? What is the value here?
332.
B,
332, ma'am.
B,
Ma'am, there's no B. 332
332
003.
003. Is it correct, everyone?
Yes, ma'am.
332, yes,
Yes,
332003.
ma'am.
Okay, fine. Yes, done.
Yes, ma'am.
Okay, next. This is again PC relative plus indirect. Okay, what is the value? What is the value? Object code
3F2
3F2
FF1.
FF1. This is negative. I think you get negative, no? Yes? Do you get
Yes, ma'am.
negative? 3,
Yes, ma'am.
3E2 I've written.
Ma'am, we didn't have indirect.
You didn't add indirect. You had or not in your question?
No, ma'am, it was only J and Gloop.
J at, this was not there.
No, ma'am.
It was not there?
No, ma'am. No, ma'am.
Then this will not be F. What was the value then? If I don't set, okay, this will be F then, right?
F only, ma'am.
Huh? I will be setting this
F only,
also.
ma'am.
F, 3F, right? 3F, 2FF1. Yes, ba? Correct. Next, SDA buffer.
0F2
0F2
00C.
00C. Okay. What type of addressing it is? It is normal PC relative, right? Okay. Next, this
Yes,
one
ma'am.
LDA EVOF
034
034
FF9.
FF9. No, just cross check, no?
Yes, ma'am, it's correct.
Yes, ma'am.
What type of addressing?
Base relative, ma'am.
Base
Ma'am,
relative.
base relative.
Okay, I put star. See, You tell me the values, no? This will be little change. Displacement equal to target address. What is my EOF?
3346.
3346. I'll just change here only. 3346 minus
Minus
minus.
1015.
Okay. So what is the value, ba? What is this value?
In decimal 9009, ma'am.
Okay. Tell in X only.
2331, ma'am.
2331. Okay, which is greater than 2047. Then go for the base relative. So this will be 3346 minus, what is this value?
334D.
334D.
4D.
Is it D?
Yes, ma'am.
Is it D?
Yes, ma'am. Yes, ma'am.
Maths. 4D. Okay. So 3346 minus 334D. Calculator is visible? Yes. Calculator
Yes,
is
ma'am.
visible. 3346 minus 334D. Yes, ma? Yes. See here.
You did ulta, ma'am.
What ba? 33.
You did ulta. 3346 minus 334D.
Yes, I did the same way. 3346 minus 334D. Yes, am I correct? Minus
ma'am.
7. Okay.
That's correct, ma'am.
Do you have
I
minus
will
7
start
in base
my-
relative? Do you have minus 7 in base relative? What is the range of base relative, ba? What is the range of base relative addressing? Can somebody tell me what is the range of base relative addressing?
0 to 4095.
Yeah, 0 to 4095. What is this value? What is this value?
Minus 7.
Minus 7.
Minus 7.
Do you get minus 7 in base relative?
No, ma'am.
No. Right. Okay. Fine. Then what you have to consider? What is the next priority? What is the next priority?
Extended.
Extended.
Extend.
Okay. Please be careful. Okay. These things, see, you have to be very careful. Okay. Fine, ba. I hope you understood, all of you. See. Yes, this one, no? I'll just share. Okay. Where is it? Maximize. Okay, this is the one, right? See here, I'll repeat. Displacement 2331, that is 90 something, which is greater than 2047, right? So instead of this 2047, now what you can write is your 7FF. Okay, right? 7FF. So then go for the base relative. So in base relative, displacement equal to 3346 minus 334D. What did you get the value, ba? What did you get? FF9, right? So this is my FF9. So which is minus, what was the value? Minus 7, right? Minus 7, which doesn't come under base relative. Yes? Are you getting me? So go for which type? Extended format. Okay. Extended. Okay. Fine. Extended format. So shall I change here? I'll just put as it is and I'll copy. I'll see here. And then this is 0 and this is 0, right? Please don't see these values because my address is different. Okay. And this is my NI, right? Yes or no? Yes or no? No. Something is going on. This is 0. Okay. Neither immediate nor indirect. This is 0, this is 0, this is 0, this is 1. So what will be here now? The direct address, no? Yes or no? What is the address of EOF? What is the address of EOF? 3346. 03346. Yes. So what will be your object code? 0. Yes. Then these 4 bits is 3 and 1 0 3 3 4 6. Okay. Am I right? Now. Yes, all of you understood? Yes, Pa.
Yes, ma'am.
All of you are there?
Yes, ma'am.
So you have to tell me the answer.
Yes, ma'am.
What is the answer now? 0 0 3. Tell me the answer, no? Yes, just now you wrote 0 3. Yes, tell the answer.
1 0
0
0
3
3 1 0
1
1
0
0 3 3 4 6.
3 3 4 6. Okay, right? Okay, next. LDA ash 0. What is the value, Ba? Is it PC relative or base relative?
Ma'am,
Yes?
ma'am, in LDA,
Ah,
EOF,
yeah.
there shouldn't we change the length also? Okay.
No, yes, you can change. You have to change. Okay, you have to change this as 4. Later the assembler will change. Okay, this is the second part of the assembler. No, initially you would assume, but later the assembler will change. Okay, fine. Then these things also will be keep changing. Okay, fine. Yes, but you will never get this type of instruction format. Please do remember that. Okay. Please do remember that because I wrote this so that you will understand how exactly the priority goes. Okay. How exactly the priority goes. Done. So you have to change this address also. Right. So this will be how much? 16. And this will be how much? 9. Right. Yes,
Yes,
so
ma'am.
that time what happens if these are there before, okay, again the addressing will change. So in real time application, these types of addressing will never come into picture. Either it will be the PC relative or base relative. Okay, fine. I just wanted you people to know how exactly it goes, the priority. That's why I wrote that instruction. Okay, ba? Fine. Is it
Yes,
clear?
ma'am. Yes, ma'am.
Is it clear? Okay. See, if you remember your any the computer like any concepts of computer organization, there will be a buffer. Okay, at least minimum 2 3 bytes of buffer extra will be allocated for that application always during the runtime. Okay, always during the runtime. So at least 2 bytes. Okay. If not more than that, at least 2 bytes of extra memory will be allocated. Okay. So this way if in case if this type of chances comes in the application, those 2 bytes will be used. Okay, fine. Those 2 bytes will
Yes,
be
ma'am.
used. Fine. So I'll just keep the previous one because otherwise your entire structure goes wrong. Okay, fine. Because you have used the C loop is there buffer. Okay, here your address you have already calculated. No, yes or no?
Yes, ma'am.
Yes. So let it be
Yes,
as it
ma'am.
is. I just mark this as double star. Okay. Fine. So that you'll come to know there is some which you have to be very careful. Okay. Fine.
Yes, ma'am. For calculating text record, we'll consider that length as 3 only, or 4.
Yeah. Consider it as no 4. Actually, I just wanted you people to know. That's why I changed. Okay. If you want me to change, I'll change it to 4 because text record cannot have more than 30. Okay. And you cannot move to the next text record. Okay. Fine.
Yes, ma'am.
Done. If I change here, no, you have to change this address also. 20. What this will become? Only this will change. Yes. Shall we change this also? No other instruction will change, only this instruction. So I'll just make the changes so that you don't get confused while doing. 16. Okay. And this will be 19. Okay, fine. And this will be how much bar? C, right?
C.
And this will
Yes,
be
ma'am.
Ma'am, LDA max also will change, no, ma'am.
what bar?
LDA max also will change, no, ma'am.
LDA, yeah, LDA max also will change. Okay, but that will be again minus 0, 0 only will come because this is one added, no? You'll get either 1 or 0, 0. Okay, the difference will
Yes,
be
ma'am.
1 byte or
Just
0
one.
bytes.
Yes, ma'am.
Okay, so what was this answer now? E. E will change to F, and this will be changed to 7. Okay, and this will be changed to B, and this will be changed to E, and this changes to C, right? Yes?
Yes,
No?
ma'am.
And this will change to 8. Okay, done. So this is 8, and this will be, what is that? 8. Okay, fine. So you will change later these things. Okay, whatever you have done previously, no? Buffer and max. Okay, please make the changes here, and now we'll see ahead. Okay, what is LDA ash 0? What is the value of LDA ash 0? Tell the value fast, ba. It's only 1 byte difference. See, whatever you have done, no? For that, you have to add 1 byte. Yes, Prajwal.
I'm calculating.
Yeah, yeah. Fine. Is it base relative? No. Is it PC relative or base relative? Yes. Is it
Yes.
base relative? Correct? No. It is base relative because it is extending the range of the PC relative, right? Yes. 334B. So here 334B minus your PC. What is my PC 1019, right? 1019. So what is this value? 334B 334B minus 1019, I feel, right? What was this value? 2332, right? So 2332, which is greater than, you can write it as 7FF, right? And yes or no? This was 7FF, right? 2047. So then go for the base relative. So 334B minus, what is the max? 334E. What is this value?
FFD, ma'am.
What ba?
FFD.
FFD. Okay. 334B minus
D,
334.
ma'am.
One second. 334B minus, how much was value? 334E,
4E.
right? So minus 3. So this also doesn't come under, is it comes under base relative? No. Okay. Again, you have to
It's
go for the extended. Okay. Fine. So that's why. Done, ba? Yes, all the next instructions are like that only because this is also base relative. Okay. Fine. So you have to make this as the base extended format. Okay. So this also will be my plus over here. Okay. And this is also plus, right? Yes, this is also plus. Okay, done. Yes,
Yes, ma'am.
these two will change automatically. Okay, you'll do at home. These two, the changes. I'll write only. Even this is also not base relative. Okay, fine. But so what will be this value?
Hello?
4F. Yeah, yeah. Tell me.
Ma'am,
Revit.
what that LDA's hash 0 instruction will do? Hash 0.
Ash
This is
0. That
immediate 0 means what you have to.
the address of this 0 will be directly stored onto the accumulator. Okay. The address of this 0 will be directly stored onto the accumulator. Fine. Yes.
Yes, ma'am.
Okay, ba. So 4F000, I'll write. Okay, done. So later you can make the changes. Okay, because this is also not base relative and this also will not come base relative. It will be my extended format. Okay, fine. So this you just make it as 4F000. And do you need an object code? Later you can calculate. Okay, fine. But in exams and all, we don't give this type of question. Okay, do remember that. Okay, because you cannot keep changing all the values whatever you have done prior. Okay, see, when I make this also 4 and this also changes again. Okay, and when you make this also 4 and this also again changes. Okay, but you have to make sure that in the exam at least one instruction will be of base relative. Okay, at least one will be of base relative, not all. Okay, not more than that. Fine, ba? Yes, is it clear? Is it clear, ba? Yes, for all of you. Hope you got it.
Yes, ma'am.
Yes, please do learn how to make, how to recognize the base relative addressing and PC relative addressing. Okay, but make sure that when you do the base relative, it should not be negative. Okay, but in the exam, you don't get it as a negative because we work out and then only we give in the question paper. Okay, fine. So we don't blindly give in the question paper when we are setting the question paper. Okay, fine. We work out first and we make sure that student won't get confused. Okay, fine. Yes. Yes. Shall I proceed? Do you need an object code for this? 3000? Do you need an object code for this? 3000?
No, ma'am.
Yes or no?
No,
Yes
ma'am.
or no? Do you need an object code for reserve word?
No, ma'am.
No. Then what is this value?
53
53. Then
4344.
4344. Okay, and what about this value 000000? Okay, if it was some 20, what could be the answer here? If it was 20, is it 00020?
Yes, ma'am.
Is it 20?
Yes.
If it was 20, what will be the answer over here?
Exa value.
X value, what is that value? 16 plus 4, 1 4, no?
Yes, ma'am.
Yes or no? Yes. So this is 00 because you have 0 over here. Okay. And there is no object code for this and there is no object code for this. Okay. Fine, ba? Yes. That's why I had I modified. No, that's why you're getting confused. That is plus, plus and all. Previously, whatever the question I had given, okay, when I had sent the question, that was correct. Okay, where you don't get extended format. Okay, ba? Yes. Yes,
Yes.
is it clear? So you please write the
Hello?
text record. Yes, Revant.
Hello, ma'am.
Yeah,
Ma'am, what if will happen if ash is not there in plus LDA ash 0?
no, that's only setting. See, only to make you people understand how to set the bet. Okay, we give ash over here. Okay, but in your applications, see, this is my common sense. Okay, see, this is equal. LDA 0 means, what do you mean by that? I hold the
Address
address
is 2.
of the 0 directly at the accumulator. Okay. If I
Yes, ma'am.
add ash, does it make sense? Not at all. Okay.
In both are same.
Both are same. Only for you
Yes.
people to understand. Okay. In programming language, that's why, did I teach you what exactly this instruction does? Did I teach you this
No, ma'am.
from beginning to end? No. I have not
No, ma'am.
taught you the day I started SIXE because we change all the instruction to make you people understand how to set NIX BPE. Okay. But when you write your
Yes, ma'am.
application, this will not be there at all. I don't need. Do you need that? See, if I write like this, there is sense. Correct? No?
Yes, ma'am.
Yes, ba?
Yes, yes.
Yes?
That's why I'm asking.
Okay. Here I've changed the code, okay, so that we make the student to understand, okay, how to set NIXBP. That's it. Okay. Did I say any time the logic of this program, ba? Did I
No,
say?
ma'am.
No, I've never explained the logic. Have I explained the logic what exactly this does? No, because it is I've
No, ma'am.
written only to understand how to set the NIXBPE. Okay, fine. Yes,
Yes,
is it clear now?
yes, ma'am.
Okay, please don't
Yes,
see
ma'am.
the logic. Please don't see the logic. Okay,
Yes, ma'am.
fine. I've written this, I've changed. Okay, fine. Because I want you to know what is at the rate, what is ash. Okay, and if I have only one register here, how exactly to set the bits. Okay, fine, ba? Yes.
Yes, ma'am.
Okay, this will never
Yes,
happen.
ma'am.
Okay, fine. When you write your MUPI program, you
Yes, ma'am.
never write like this. Okay, you might write this. Okay, store that address directly, but I never
Yes,
write
ma'am.
#0. Okay, fine, done.
Yes, ma'am.
Okay, bro.
Yes, ma'am.
So text record, end record, and the header record, please do write. I'll just make all these modifications later. Okay, fine. So I've not written the fourth question over here. So I hope all of you have done it. Okay, all of you have done the fourth question. Yes, all of you have done the fourth question. You people said no, I had given 4 questions. Yes. Somebody there. Pratik? Pratik is not there?
Ma'am?
Pratik.
Yes, ma'am.
Pratik is not there.
Yes, ma'am. Yes, ma'am.
Okay, fine.
Yes, ma'am.
What, ba?
Ma'am, I'm there, ma'am.
You're there. Okay, fine.
Hello. Yes, ma'am.
Okay, ba. Fine.
Ma'am, in the fourth question,
Ah,
there is no value for marks, ma'am.
what, ba? Hello? Yeah, tell me, Pratik.
Hello.
Hello?
In the fourth question, ma'am, there is no value for base, ma'am. Base. There is no base value.
Oh, not required. Fine. If it is not there, then do you get base relative?
Yes, ma'am.
Okay, then you can add. Okay, I'll just add it and send. Okay, fine. And one more thing, I wanted you people to know this. Okay, fine. See here, the opcode. Suppose in the question in the exam. Okay, in the exam, all of you are there, ba? Please do listen. If I am not given RSAP, okay, if this is not given, okay, but this instruction is there in my the question, okay, fine. RSAP instruction is there in the question, but when they are giving the opcode, they have not given the value for RSAP, okay. You have to assume the value, no? Do you agree? Yes, ba? I have to assume the value,
Yes.
right? Yes,
Yes,
or
ma'am.
no? I have to
Yes,
assume, you have to write assumption, okay. Assumption RSUB equal to, okay. How do you assume the value? Okay, what are the possibilities which you can assume the value is? See, this is how many bits, ba? 6 bits, right? And out of 6 bits, 4 bit is, how do you write this 6 bits? Suppose I write 0000, okay, fine. So this one, the first 4 bits, I can extend up to where? 002 FFF. Do you agree? Yes, ba? The first one, the first 4 bits, you can write from 0 to FFF. Okay, 0 to F. Done? The first bit could be the first 4. The first nibble can have value from 0 to F. Okay, fine. 0 to F. And next is How many bits are there in the next nibble? Only 2 bits. Correct, no? Yes or no? Are you people listening? Yes? Pratik?
Yes, ma'am.
Yes.
Yes, ma'am.
So I have only 2 bits. Correct, no? And I'm assuming that the remaining 2 bits are 0, which are meant for my ni. Right? So what is the value you can store? 0, 0. Okay, fine. I'll write here 002 FFF. Okay. Next, the next nibble 00. Okay. I can set this as 00 or 01 or okay. Then 10 or 11. Okay. Fine. I can set this as these many, right? Are you getting? Either 00 or 01, okay, or 10 or 11, okay. So what is your binary equivalent? This will be 0 or it could be 01 is how much? 01 is how much? 4, right? Or 8 or C. Are you getting? Yes? 0, 0 is 0. 0, 1 is remaining 2 bits are 0, that is 4. 1, 0 is nothing but 1, 0, 0, 0, that is 8. 1, 1 means 1, 1, 0, 0, that is 12. So this is C. So what I can assume R sub 2? R sub 2 what I can assume? So you can assume R sub either 0, 0 or 0, 4, okay, or it could be 0, 8, okay, fine, or it could be 0, C. Done. These are very important for me. 0, 4, 8, C. You cannot make this you cannot make the value of these 2 bits apart from 0, 4, 8, C. Okay. If I make it as B, can you represent B in 2 bits? Can you represent B in 2 bits? What is the value of B? 11. Can you represent 11 in these 2 bits? Can you do that? Can I do that?
No,
No,
ma'am.
ma'am.
No. Can you do that? No. Can I
No,
write
ma'am.
this as 4A? Can you make this as 4A?
No, ma'am.
No, not at all. What is 4A? 10. 10, no. So can you represent 10 using these last 2 bits? No, it's only 4 and 8. So see here, nowhere the second nibble is apart from these values. Can you
Yes,
check
ma'am.
out here? Do you have apart from 048C?
No, ma'am.
No. The first 4 nibbles you can the first
ma'am.
4 bits you can change up to from 0 to FFF, right? Yes, ba? Yes, sir. No. F. Sorry, not FFF. 111. Okay, that is F.
Yes, ma'am.
Correct? No, not FFF. It is 111. That is my F. Okay, done. Yes, ba? Yes.
Yes, ma'am.
Right? See here, the second 2 bits is only 0, 4 or 8 or 0. This is also 8, this is 8, 0, C, then 0, 0. The first one is from 0 to F, okay? From 0 to F, okay? Done, ba? Can have you, that is the first nibble can have from 0 to F, and the second half nibble can have values from values of okay, that is 0, 4, 8 and C. That's it. Okay, fine, ba? So when you're making an assumption, if any of the opcode is not given, you have to be clear or you have to be careful with the second 2 bits. Okay, done. Yes, is it clear? Yes, ba? So actually I had not
Yes, ma'am.
given here, I added one no clear X, okay, but actually that opcode I had not given. So that I can teach you this, but you said it was not there, right? I just deleted, okay, ba? So make sure that you write 048C only. If any of the opcode is missing, in the question paper. Okay, fine. Yes, any more doubt? Any doubt? Any doubt?
No,
If you have a doubt, please do
no,
ask.
ma'am.
Okay, fine. And please do learn carefully. Don't make mistake. Okay, because this is the first question in part A. Okay, you get module 1 question, no? So out of that, one question will be of your that is SIXC registers or data formats and all. And second question will be of finding the object code, or it could be of pass 1 of pass 2 algorithm. Okay, write an algorithm, write the pass 1 algorithm of 2 pass assembler. Okay, fine. 2 pass assembler in the sense you have to write the pass 1 algorithm of that. So that is your location counter values. How do you do all these stuffs? That means if it is a reserved word, you have to multiply by 3 stars hash operand. If it is a word, add 3. If it is a byte, count the number of characters. Okay, and if it is a reserved byte, then convert that into that is directly hash operand. Okay, so that will be my location counter values. Okay, fine. Any doubt, ba? Any doubt? If you have a doubt, please
No,
do
ma'am.
ask. Well, why Mithun left? Why Pratik? Pratik?
Yes, ma'am. Yes,
Ask
ma'am.
Mithun, no? Does he have some urgent work? Okay,
Yes, ma'am.
fine. So yes,
Okay.
so once you learn from the book or notes, if you get any doubt, please do ask me. Okay, fine. So this is of your SIC and SIC machine architecture, where you have learned both pass 1 and pass 2 algorithm. So we'll move to the next topic, that is program relocation. Okay, program relocation. So what do you mean by program relocation? Why do I need a program relocation? This is only 10 minutes. Okay, fine. We'll just complete. Done, ba? So what exactly happens is, in your operating system, okay, you have written your application and you want to execute that on your operating system. So when you say control F9, that is execute or run, okay, OS will allocate one process for your application. So it will check when it wants to allocate a process for you. Of course, it will check whether that particular memory what you are asking for is free or not. Okay. Suppose I'll ask for the memory address 1000. Okay. That means my program should start executing from the address 1000. Now all of you are clear. When I say start from 1000, that is the instruction given to the loader, right? So if that space is not available, what do operating system will do? Either it will ask that particular process to wait in a queue, or it will check if any other memory of those many bytes. Okay, I need 1500 bytes. If that memory is free, it will reallocate your program. Okay, so this is when the memory is not available. That is, that particular memory is of course a resource which is shared by every program, right? Or when you do the multi-programming, okay, so you do the context switch. You have learned context switching? Yes, ba, you have learned context switching in OS. Do you agree? Yes sir, no? Have you learned context switching? Pratik? Yes.
Yes, ma'am.
Yes, ba, please be alert. No. Yes. Have you learned context switching? Yes sir, no?
I haven't gone through that.
Context switching. Mutual exclusion, critical section, semaphores. You people have not learned all these things?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Semaphore is one of the
Yes, ma'am.
stuff what you use for context switching, right? Yes, critical section you have learned, no?
Yes, ma'am. Critical section. Yes, ma'am.
Yes. Monitors you have learned? Monitors.
Yes, ma'am.
Yes,
Yes, ma'am.
Revant, Mithun. Yes?
Yes, ma'am.
Okay, so what do you mean by context switching? I'm running
Yes, ma'am.
multiple process, right? And I don't want other process to wait for a long time. What I'll do, I'll run for some duration I'll just do the context switching. I'll allow the next person. You have so many types of algorithms. No, that's scheduling algorithms. Either priority based, round robin, or first come first serve. All those comes under your scheduling, right? Context switching. So you will be keep doing, right? So here what happens? I don't want to do that. Okay, I don't want to do the context switching. Fine. I don't want to run for 2 minutes and I run the next program and again do the context switching. That again a tedious process. Okay, if you see practically, okay, that's very tedious process. You just wind back all the addresses and get back the different process addresses, all those stuffs. Okay, so that time I don't want to do context switching in multi-programming concept. Okay, so that time you go for the program reallocation. So there are the situation where you go for the program reallocation is during multi-programming, and there is a resource which is shared, of course, as memory. Okay, memory is a shared resource. Okay, so that time first memory is shared by somebody else, so I don't want to wait in a queue. So there is already available memory where I can load my program and run peacefully. So that time I go for the program relocation. Okay, fine. So what do you mean by program relocation? It is a process of modifying the address, okay, used in the address sensitive instruction programs such that the program can execute correctly from the allocated memory area, right? So the object program which does this is called as relocatable program. Okay, the object program that contains the information necessary to perform this kind of modification is called relocatable program. Okay, see, now the question is, can assembler identify whether this is address or this is a constant? Can it identify assembler? No, it doesn't know. It only knows that it is my object code. Okay, it doesn't know whether this is address or this is a constant what I have stored. It can only instruct the loader saying that you load from this particular address. Okay, this particular address. So that's why it is relocatable program. This is achieved through modification record. Okay, how do you do that? How do you achieve the program relocation? That is nothing but the modification record. Okay, see, what do you mean by object program? It is a combination of my header record, text record, and the end record. Along with that, I have to instruct, okay, to the loader saying that make these changes during my program execution. Okay, when do you need that? There are some instructions in my assembly program which are very sensitive. Okay, which are very sensitive. What do you mean by sensitive is it has to be loaded at that particular address itself. I don't know how to run when I change my address. So that's why here address sensitive instructions. Okay, fine. So we'll just see how exactly you can do the program relocation using for SIC machine and SIXC. Okay. See, if you remember in SIC, what are the two different addressing modes? One is direct, correct? No? Yes or no? What are the two different addressing modes? Direct and
Direct and indexed.
indexed. Right? So what do you mean by direct? I just directly write, correct? No, opcode I'll write. I'll directly write the address of this. Correct? Yes or no? Address of this instruction. Do you find the displacement over here in SIC machine? I never find the displacement of any of the instruction in SIC because I don't have the format itself, instruction format. So I have all direct and indexed. So if suppose it is starting address is 2000 in SIC, and if that is not free and it says that the 4000 is free, okay, so I have to load my program from, sorry, it is 3000, so I have to load the program from 3000. So this has to be changed too. See, when I load at 2000, the memory what it takes is 314, that is 2000, right? In 2000 it will be 04, 2001 will be 31, and 2002 will be 41. I have to relocate. Okay. So I'll start from this 3000. That has to be changed to what? Right? So this has to be changed to 1000 ahead. No? Yes or no? Do you agree? 3141 has to be changed to 4141. So in SIC, all the instructions has to be changed. Why? Because all are absolute addresses. Okay, we call them as absolute addresses, direct address. Okay, I don't have any displacement at all. Okay, so that I just change, and from that displacement I go for the from the base address I go for this much offset. That is what you call that as a displacement, right? So then I'll execute. There is no such cases in SIC machine. So here, why so? Because all are absolute addresses. This is very tedious in SIC. Okay, every instruction has to be changed. See here, TIX count, it starts at 2003. If I start at 3000, okay, so obviously why I have to start at 3000? Because there is that memory is not free, but the memory from address 3000 is free, so I can relocate. Okay, when I agree to relocate, every address has to be changed. Okay, fine. So this is one problem with the SIC machine. Okay, when you come to SIC XC, you have different types of addressing, correct? No? Yes or no? See, this is, you have PC relative addressing, base relative addressing, and you have extended also. In PC relative, what do you people do, ba? You will find the displacement. Do you agree? Yes or no? Yes, in
Yes,
PC
ma'am.
relative and base relative, you will always find the displacement. That means I have a base address and add the offset, I will get the current address. So you see here, except for absolute addresses, the rest of the instruction need not be modified. What are the rest of the instruction? Immediate addressing I don't need. I don't have to change PC relative. I don't have to change base relative. Okay. The only parts that require modification at load time are those that specify direct addresses. Which are those address types? Can you tell me which format is that where we write only direct address? Can you tell me which format in SICXC where we directly write the direct address at the object code?
Extended, ma'am.
Extended, good. Okay, this is only the one which I need, right? Extended format. Done, ba? In SICXC, this is the only format where we write direct address, extended format. Okay, fine. So I have a program over here. Okay, fine. See here, starting address was 1000. Okay, and the operating system says that the 1000 is not free. Would you like to relocate your program? Okay, so I want to relocate to 4000. See, if you agree, then only OS will allocate. If you want to, if you are ready to wait in a waiting queue, then obviously the process will be put onto the waiting queue. Okay, you have that process state diagram, no? I hope the first chapter says about that process state diagram, right? Where you learn PCB, process control block, all those stuffs. So if I am ready to relocate my program, then this has to be changed. Okay. So that how do you do? Along with the, does your assembler understands these instructions? It knows that only the byte, all those stuffs. Okay. It just loader. It has to give instruction to the loader. Okay. So here, please tell me, do you need this address change? No. Fast, fast, fast. Okay. Do you have to change this address? Yes or no?
No, ma'am.
No. This one? No, right?
No.
No, this is also no because this is my immediate addressing. So irrespective of my location, I just have to load 00 over here. And irrespective of my address, wherever, okay, so I have to load 10, okay. And do you need the changes over here? Do you need a change
Yes,
here?
ma'am.
Yes, why
Yes,
it
ma'am.
is? Because it is my extended format, okay, and where I store the address of table 2 directly over here, that is 0334E. Yes, ba? 0334E I'm storing. So this also I don't need. This is also not required because these are all either PC relative or base relative. Okay, Fine, because where you find the displacement. So what is the next instruction which needs modification record? This one, because this is my extended format. Okay, remaining instruction I don't need. Okay, so how do you achieve that? See, this is what it looks. See, I have loaded from 1000. Okay, I have written this, that is LDB ash. Okay, 10334E, and that is the address of my table 2. When I relocate, okay, when you reload at 4000, this has to be changed to what? 6910334E plus 4000, that is 734E. Okay, fine. But can assembler change this? Can assembler directly change this? Yes or no? Can assembler change this address directly before loading? Yes, Neha, Aishwarya. Can assembler change this address directly? Yes, Prajwal. No, because assembler doesn't know where exactly your program will be loaded during runtime. Okay, so it cannot make the assumption. Fine. Only it can instruct to the loader if you are not loading at 1000. Okay, if you are loading my program at some other address, please make the changes to these types of instruction. That's it. Okay. Yes. Okay, so it has to be changed to this address, but it cannot make, the assembler cannot make this, okay, prior, unless it knows. But it doesn't know. I don't know where exactly my program will be loaded during runtime. Okay, fine. So this is the pictorial representation. What do you mean by program relocation? I want to load at this. I don't have that memory free, so it will be relocated or reloaded at 4000. When it is reloaded at 4000, this address has to be changed. Okay, so what assembler does? Assembler gives the instruction saying that this at this particular address make the changes. Why so? Because these are address sensitive instruction. What do you mean by address sensitive instruction? Is where I am storing the direct address as one of the object code, a part of my operand. Okay, fine. So that is done using modification record. Okay, see here, what do you mean by modification record? Is column 1 says M. Okay, 2 to 7 starting location of the address field where it has to be modified relative to the beginning of the program. Okay, and column 8 to 9, that is two columns, length of the address field to be modified in half bytes. Okay, so what is the length of this instruction, ba? What is the length of this instruction? 4 bytes. Do you agree? Yes. So how many nibbles are there here from here to here? Yes, yes, fast. How many nibbles? How many nibbles?
5.
5.
5 nibbles. Is it complete byte?
No,
Is
ma'am.
it is two
No.
and a half, right? 2.5 bytes. I cannot
Two
say
and a half.
2.5 bytes. So it is half bytes. So I say that it is 5 nibbles. Okay. So that's why here you have a, see here, length of the address field to be modified in half bytes. Okay. Why? I've written address is 20 bits. That is my 5 half bytes. So that will be again 5 fours are 20. Okay. Please do remember this half bytes. Okay. Fine. So I've just again copied the same so that you'll understand how exactly you have to modify it. So I'll modify these two instruction. Okay. This has to be changed and this has to be changed. How does your assembler instruct says, see I've written this 1000A LDB ash table 2. So I've written completely the address. Okay. So 0F10 no 6910334E. Okay. Can you people say this? See here 6. Is it 6?
Yes,
LDB.
ma'am.
It is not 6, no.
It's 5.
It is 5. What is LDB? Okay, that's fine. Anyway, I've written 6 means it has to be 10, right? Yes? Is it 6
Yes,
now?
ma'am.
6.
Yes.
And this is 9.
Yes.
This is 9 ba 1001.
Yes,
And
ma'am.
next is 1. Okay,
1, ma'am.
extended format. And 0. I can write directly here instead of writing. No, you can write directly. I've written just to make sure that you understand. Okay, fine.
0, 3,
Ah,
3.
0, 3, 3, 4E. Okay, fine. So this is my 20 bits. Okay. Now, what do you mean by 1000 A, 100A? So in 100A, this has to be loaded. And in 100B, this 1 byte has to be loaded, right? And 100C, this is one nibble and this is one nibble, and here one more. Okay, so I've written here somewhere. Okay, fine. So this indicates that control uh, ex. I'll just do it here. See, what do you mean by that? 1000 here. See, 1000 sorry, 1000 A. What has to be loaded? What has to be loaded? Ba 6. Yes, 69. Then this is 10 and this is 33 and this is 51. Do you agree? Yes. A, B, C,
4E,
D.
ma'am. 4E, ma'am. Not 5-1.
4E. Sorry. Is it clear? Yes, ba? So this instruction indicates that at 100A, 100A, 1 byte, that is 69. Okay, this is 1 byte because this is 2 nibbles. At 100B, 10 has to be loaded. Okay, and C 33 has to be loaded, and D it is 4E. Okay, because this is 1 byte. Okay, so this is 1 byte, this is 1 byte, this is 1 byte, and this is 1 byte. Totally 4 bytes. Okay, now what I have to say, see here, I have to modify these many because this is my direct address. Do you agree? These 20 bits are my direct address. Is it direct address? No, it is a part of my bits, NIX, BP and this much. So I have to indicate to the, I've written already the text record. I have to write the modification record. And what is your modification record says? 1, 2 to 7 is starting location of the address. Okay, starting location of the address. See here, starting location of the address field to be modified. So what is the starting location of the address field to be modified? Yes. See here, where I have to modify this one. Correct, no? 100B. Yes or no? 100B. This is 1 byte actually. This total is 1 byte. That is 10 is 1 byte. But I don't need to change 1. Okay. So 100B, that is 100B. And what is next? 8 to 9. 8 to 9 is length of the address field to be modified in half bytes. Okay, length of the address field to be. So what is the length of that? 05. What is the length of this bar? How many nibbles? How many nibbles? 5. That is 5 half bytes. Okay, 100. That is 0334E. 20 bits is my 5 half bytes. Okay, so M is my modification record. And 0, it is my starting address relative, okay, to the first address. Done. And 05 is my half bytes. Okay, how many bytes I have to change? So this is instruction to the loader. Okay, modification record is always an instruction to the loader. When you come at 1000B, okay, see here, this is 1000A. Do you please make sure that you understand? 69 is 1000A and 10 is 1000B. 10 is 1000B. So what is this indicates that when you come at 1000B, okay, and this will tell me how many half bytes you have to change. So how many half bytes have to change? 5. Okay, till here I have to make the changes over here. Okay, so this will be changed to what? Relative to the base address. Relative to the base address, that is my starting address. Where I have loaded my program now? At 4000. Correct? No, I am loading my program at not 1000, at the address 4000. So this will be added. 0334E will be added to, that is 0334E plus my starting address 4000. So what will be the answer? 0734E. Okay, it will load this instruction at 034E. Okay, done? Yes, ba? Yes. So here again I have one more modification record to be written, because this is also my direct address. Okay, so what is this address? 101A, you have to tell me. And what this will be? 101B, right? And this will be 101C, and this is 101D. Yes, okay, yes. So can you tell me where I have to make the changes? See, my 5 half bytes are 03351, because this is a part of my NIX BPE. I cannot change this. So the first 3 nibbles remain as it is, and I have to make the changes only to the next 5 nibbles, that is 5 half bytes. Okay, fine. So where do I make the changes here? So this will be M. Can you tell me the answer? Where I have to make the change? Yes, Prajwal?
Yes, ma'am.
Where I have to make the change, ba?
101B.
101B, yes. So this is 6, no? 101B, okay. And how many half bytes?
5 half bytes.
5, okay. 05, okay, fine. So yes, so this is my blue, and this is, okay. So what do you mean by that? Where I have to change? When it starts loading at 101B, where is my 101B? 0F, right? So 0F is somewhere. Where is it? 10, here. Okay,
Last
fine.
one. Yes.
0F, when it comes this address, that is 101B, and I have to make the change. This is my 101B actually, right? And I have to make the changes here. Okay, these 5 half bytes, that is 5 nibbles, has to be changed to what address? That is 3351 plus 4000. I have given the here the relocatable address is 4000. Okay, if it is 7000, that will be changed automatically. Okay, please do remember that modification record are the object program, what is the output of my pass2, gives me the instruction to the loader saying that this is my starting address, and keep loading this instruction from that particular address. Okay, so if I make changes in any PC relative or base relative, so how do you find? Why I don't have to make the modification record for PC relative is, see, how do you write PC relative addressing? That will be, you will be checking out for the displacement, correct? No, in PC relative you say that displacement is always target address minus PC. Do you agree? Yes, ba?
Yes, ma'am.
My target address was 1000, suppose, initially. Okay, my PC was some 003. Okay, fine. So what will be the address now? So I say that 1000 minus 003, how much, ba? 1000 minus 3.
FD.
FD.
Okay, fine. So this will be FFD. Now I'll change my target address to how much? I'll just change. This was my 1000. Okay. Suppose I change to 4000. What will be the address now? 4000 minus PC will also change, no? Yes, sir, no? Yes, sir, no? Yes?
Yes, ma'am.
Calculator. Okay. So if I make this as 4000 minus 3 FFD. Okay, it will change automatically. Correct? No? Yes, sir, no? Yes, are you getting?
And
This also will change, right? Your 003 will also change, right? 1000, if I make this as 4000, this will be 3003. So I'll get it as again FFD only. Yes or no? See, my PC, I'll just show here. Okay, just show. Done, ba? See, this is my PC relative. Okay, PC relative. This is PC relative. Okay, I'll change this to 4000, 400E. And directly this will be added amount. Okay, where is my amount? This will be 4026. Yes, 4026. So what will be this address? 400E minus 4026. I should get 015. Do I get 400E minus 4026?
ma'am, calculator is not visible.
Calculator is not visible. I'll just
FE8.
FE8. What was this address now? 015. Did we change properly? Amount only, no? So this I changed to 4000E, and this was how much, ba? Control. So this will be 5, right? Plus 4000. Yes?
Ma'am,
Ah,
but we take PC value as the next value, no, ma'am. Like,
PC value is next value. Sorry. Okay. So this will be 433E. Thank you.
yes, ma'am.
43334E, right? So this will be
Not there, ma'am. Like, add amount comma x, the next value of that, ma'am. Like 4011.
full.
Address of next
Oh,
instruction.
yes. So this will be target address is 4026. Okay, correct. And this
And
will
PC
be
value is 4011.
4011. Okay. Now I think that will be correct. Yes. 40. Somebody is saying that calci is not visible.
15. 15.
15, huh? Did you
Yes,
get?
ma'am. Yes, ma'am.
4 4026 minus how much ba? 401.
4011.
Okay, so that is 15. Yes,
Yes, ma'am.
done. So that will be irrespective of the address, the displacement will be keep changing automatically, right? So whenever you have PC relative, I don't have to worry of changing the what is that object program, because it is always with respect to the base starting address. Okay, even in base relative also it is same. Okay, when you come to addresses like this ash 0, this is my direct address. Okay, which will be always in data segment, correct? No, so I just fetch the value from there, I store it in that particular register. Okay, so I don't have to worry about your immediate addressing and your PC relative or base relative. So where you are storing the direct address as part of the object program, that is object code, you have to make the changes. Okay, but that cannot be done by the assembler. Okay, fine. Your outcome of assembler is already done, the pass to is already executed. Okay, so I cannot make the changes again. You can only instruct to the loader through the modification record, saying that whenever you are loading the instruction at this address, that is 100B, please change the remaining next, that is next 5 half bytes to what? To the relative of the base address where you are loading the program. Okay, during my runtime. Okay, so that's why assembler cannot make these changes during the during the compile time. Statically it cannot do, it has to be done dynamically. Okay, fine. So this indicates that to the loader, when you are loading my instruction at the address that is 100B, you please make the changes in the next 5 half bytes. You make the changes relative to the starting address where you have loaded my program. Okay, fine, ba? Is it clear? Is it clear? Yes,
Yes,
any
ma'am.
doubt?
Yes,
So
ma'am.
this is my modification records. Okay, fine. So your object program will be having header record, text record, and the modification record and the header record, your end record. Okay. So fine. So this is with respect to the program relocation. When you go for program relocation, whenever that particular memory is not available, okay, that is if it is a shared memory, then obviously you go for your program relocation and during my multi-programming concept. Okay, that is your context switching, all those stuffs. Okay, so that time you go for the program. See, you have learned in operating system fragmentation. Yes, all of you have learned fragmentation. Yes or no? Yes, have you learned fragmentation? Oh yes. Rajwal, you learned or not?
Yes, ma'am.
Yes, fragmentation, internal fragmentation, external fragmentation, paging.
Yes, ma'am.
Yes, that's what. See, fragmentation means what? I'll allocate some memory, I'll not use it. That will be left as whole only, no? That is, it is not being used. I'll allocate some.
Yes,
We'll
ma'am.
see when you're, for example, at day-to-day life, we do this. See, when our laptop becomes very slow, we do the fragmentation. Yes or no? You can see, right? We do the fragmentation. That means we shift all the spaces, right, to one side so that our laptop performs faster. Okay, right? Yes. Do you do it or not?
Yes, ma'am.
Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes.
ma'am.
Yes, ma'am.
Right, you can see those no blocks will be left in between, and which you what is that fragment all those stuffs and move to the end so that your any processor will be performing faster. Okay, fine. Instead of putting in a queue, what I do, that's what you have learned as the paging or moving all the unnecessary bytes to the end. Okay, fine. I'm not getting the word. You say some word, no, in operating system. You'll allocate 100 bytes, but you'll use only 50 bytes. 50 bytes is left as it is. And from 101, you'll allocate to somebody else. But there's one more process which comes requesting for 50 bytes. It says that the memory is not free and it will put it in a waiting queue. Okay. Even though you have 50 bytes free from 0 to 100. Yes? Yes. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Okay, fine. So please do learn OS properly. Okay, fine. That is the basic foundation for any of the CS student. Okay, ba. So I hope all of you understood program relocation. Yes. So we'll just see in the next class the assembler independent features, that is the literals, then equations and all. Okay, next class. Any doubt, ba? Program relocation. See, in the exam, no, you don't have to write what is there in the textbook only. So you have one example which says the biggest program in the previous one. What do students do is they'll write the entire program and they'll explain. No, what you can do is just write only these two instructions and before that one instruction, okay, and after this one or two instructions, okay, that's more than enough. And any number whatever comes to your mind you can write that, and based on that you can write this part is required for marks. Okay, this is required, so this comes for 6 marks. Program relocation. Okay, what do you mean by relocatable program? Explain with an example. Okay, fine. So you have to say what do you mean by program relocation and relocatable object program, and one example. Please don't write the entire thing. Okay, fine. You should understand the concept. You should filter out and write in the exam. Okay, so this some 4 instruction where you have plus has to be there. Okay, where you have to say that this instruction I don't need to modify. Okay, the previous one, this one I don't need to modify, and this one I don't need to modify. Right, I have to say, right, why I don't have to modify, and modification record you have to say, and next is this much. That's more than enough. And this you can put dash dash dash. Okay, fine. What I need is these two, and header record you can write, and text record, end record. Okay, H, T should be there, M should be there, and E should be there. M is very particular. Okay. That is very important when you write program relocation. Okay, ba? Yes, any doubt? Any doubt? Yes. Hello?
Hello, ma'am.
Yeah, any doubt, ba?
No, ma'am.
Any doubt? All of you are very down today. No, nobody is in a mood to learn. Yes? Yes, any doubt?
No, ma'am.
No, ma'am.
Any doubt? Any doubt?
No, ma'am.
Okay. Shall we end the session? Yes?